Hello everyone, welcome to Skilled Dev. Trey here, and in this lesson, we are going to solve Interview Scheduler. This question is told as a story where you're the manager of an engineering team and it's your job to hire candidates. To make sure they have a good experience, you want them to meet the entire team. And to do this, you need to know when your team has meetings. To find a schedule that works, you ask everyone to send you their meeting times so then you can determine the overlapping meetings to make sure those are blocked off. Then you can schedule a time for everyone to meet the candidates. So this prompt states, write a function that returns an array of intervals where the input intervals with overlapping start and end times are combined into a single interval. So the input to the question is intervals, and then the output of the question are intervals that are combined with overlapping times. And in this question, we're going to use the terms interval and meeting interchangeably. An interval just refers to a block of time, which is equivalent to a meeting with a start and end time. So it's worth noting that all of them will be standard times, so it could be anywhere from 0 to 24, and then the 0.5 just means a half-hour increment. And we're given the constraint that all times will either be a whole number or only use this 0.5. So the first meeting starts at 9 and ends at 9:30. Then we check the second meeting. This one starts at 9:30 and then ends at 10. Well, this meeting starts before the previous meeting ended, so then we combine them into a new block of intervals. Then we move forward and see the third meeting starts at 10 and ends at 11. Well, the previous block of meetings went from 9 to 10:30, which was the earliest start time and longest end time, and this meeting starts before that one ends, so we combine it with this block as well. Then we get to the fourth meeting that starts at 10:30. Well, the previous block of intervals starts at 9, and then we saw after we merged the third one that it ends at 11. Well, this fourth meeting starts at 10:30, so it starts before those previous block of meetings ends, so this is combined as well. So this first block of meetings starts at 9, and then ends at 11:30, which includes 4 overlapping meetings within this entire interval. Then we move forward. We get to the fifth meeting, and 13 comes after the end of the previous block of combined intervals, so we start a new block of combined intervals. We get to the last item. It starts at 13:30, which comes before the end of the previous meeting, so then we combine these two together. This gives us a second block of combined meetings that goes from 13 to 15. So let's take a simple sample input and visualize what's happening. We have these two meetings in the input, one that starts at 0 and ends at 4, and one that starts at 3 and ends at 6. We can see they're clearly overlapping. We have the 0 to 4, and then starting at 3, meeting 2 begins, and then ends at 6. So since they're overlapping, they need to be combined. Meeting 1 plus meeting 2 goes from 0 to 6 as a combined block. So how do we know this? Well, let's really state it and understand it explicitly. The first meeting starts at 0 and ends at 4. Because it ends at 4, the next meeting, which starts at 3, started before the previous one ended. And because it started before the last one ended, we know they must overlap. Therefore, they're combined from 0 to 6. So now let's expand the example to consider 3 meetings. The first 2 are similar to the last case. We have 0 to 3 and then 2 to 5. So we would combine these first 2 meetings. Clearly, meeting 1 and meeting 2 overlap. So now their combined interval starts at 0 and ends at 5. So what about meeting 3? Well, meeting 3 doesn't overlap meeting 1. It starts at 0 and ends at 3, but it does overlap meeting 2, which starts at 2 and ends at 5, And because it ends at 5, and meeting 3 starts at 4, these are overlapping. So when we consider the combined interval of meeting 1 and meeting 2, which ends at 5 because meeting 2 ends at 5, this will also include meeting 3. Because meeting 3 starts before the previously combined block ends, which went from 0 to 5 because we combined meeting 1 and 2. And now with these 3 combined meetings, it goes from 0 to 7. So because meeting 1 is the first meeting of the day, we start there. And we know it's the first meeting of the day because it has the earliest start time. And then it ends at 3. So meeting 2 starts before meeting 1 ends. So because the next meeting we're looking at comes before the end of the prior meeting, they're then combined in the same block. And then finally, we consider meeting 3, which starts at 4 and ends at 7. Well, meeting 3 clearly doesn't overlap meeting 1 because it starts after meeting 1 ends. So meeting 1's end time ends prior to meeting 3, but after we recognize that meeting 1 and meeting 2 overlap, they form a new combined interval, so we treat them as a single unit that starts at 0 and ends at 5. And since meeting 3 overlaps the combination of meeting 1 and meeting 2, it is also combined. So let's explicitly state what we're doing. How did we know we're combining these meetings? So what we were doing was walking through the array of meetings, starting with the earliest meeting, and then checking its end time against the start time of the meeting that comes after it. If the start time comes before the end of the prior meeting or combined intervals of meeting, then we also combine it. And we considered them by the start time. So meeting 1 was the first meeting because it started the earliest in the day. The meeting 2 was the second meeting we considered because the start time was the second earliest. And then finally, we considered meeting 3, which had the latest start time of these 3 meetings. So since a meeting must obviously start before it ends, the important new piece of information as we walk through each item is the start time of the next meeting. And then we just compare this to the end time of the prior meeting or prior combined interval of meetings. So up to this point, it's been pretty simple and straightforward to understand how to combine meetings, but what if we're given a more complicated input that looks like this? Well, previously the meetings were ordered. We saw when the meetings occurred throughout the day based on when they started. But we're not guaranteed to get this order. These meeting times can be given to us in any arrangement. They're just randomly coming from the employees as they understand what their schedule is. So now let's imagine we're iterating through this input. We have meeting 1 that starts at 0 and ends at 3. Well, now we want to see what other meetings might overlap it. Since the meetings can be in any order, a brute force way to approach it would be to start at the first meeting, check its start and end time, and then iterate through all the meetings in the array to see if they fall within this interval, and then combine them, and then continue to check this combined interval with all the other items. Then you would move to the second item, and then compare its start and end time to all the other meetings again. So you would just do this in nested loops for every item. So this is brute force, and because we can recognize it would take nested loops, we know it would be O of n squared quadratic time. So we recognize we could receive the input in any order, and because of this, we couldn't simply just check each item that its start time came before the previous end, so we would have to use this quadratic time to make all the comparisons. So what if, instead of doing that, we did order this? We sorted it so then we could just make these comparisons one after the other. Well, to sort, we know this is O of n log n, so this is better than O of n squared, so it's an improvement over that brute force approach. Then the question is, what do we sort by? Well, we saw that when we checked each new meeting, that key piece of information was when the meeting started. Because obviously a meeting must start before it ends, the key piece of information to know where a meeting appears on the schedule is that start time. So then when we iterate through and combine them, we can always just check the end of the current meeting or combine intervals of meetings, and then compare that next item's start time to whatever the previous end time is. So the new piece of information is the start time, and we compare it to the end time of the interval we're already tracking. So to get these meetings in order, all we have to do is sort by the start time. Then we can simply walk these items one by one, then at the current item, just compare it to the item behind it. So if we sort this input array, we see that meeting 3 actually comes earlier. It overlaps with meeting 1, so we combine these, but meeting 2 does not overlap with this interval. So we sort the meetings by start time, walk through them one by one. We have 0 to 3 for meeting 1, and then meeting 2 goes from 2 to 5. These overlap. So we combine them for the output, which is meeting 1 and meeting 3. And then meeting 2 doesn't overlap any other meetings, so it's simply 7 to 10 in the output. So the foundation of this solution is really all about that sort. Without this being sorted, the only way to make comparisons is a brute force O of n squared, where you're just checking each meeting against all the other meetings. But then, when we sort by start time, we get the meetings arranged as they occur throughout the day. So instead of comparing it to all the other meetings, we only compare each item to the previous item before it, or the previous combined block of intervals before it. So we start with meeting 1, and this begins the first interval. Then, since it's ordered, the next meeting on the agenda, meeting 5, starts at 1 and ends at 5. Well, this meeting's start time comes before the previous meeting's end time, so we combine those into a single interval. So there's only one comparison to be made. This is because every meeting after this one must come after the current start time. So this meeting is either within the previous interval, and if it's not, then it would start its own new interval, and we wouldn't have to consider any other meetings. So by sorting it, we get one comparison at each item as we iterate through. So then, we move to meeting 3. Once again, there's only one comparison, and we see meeting 3 starts before the combination of the previously combined intervals ends. So then meeting 3 just joins meeting 1 and meeting 5 in the same block. Then we move to meeting 2, since it's the next one to start. The start time for meeting 2 occurs after the end of the previous block of meetings. So we know no additional meetings will ever belong to this first block, because all their start times must come after meeting 2's start time, and meeting 2 is not within the first block. So the first block of combined intervals is meeting 1, 5, and 3. And then we start checking for the next block, and it begins with meeting 2. We finally reach meeting 4. Meeting 4's start time comes before meeting 2's end time, so we combine those. And that's the solution. So the output is going to have 2 blocks of combined intervals, from 0 to 6:30, and from 7 to 11. And we solved this by sorting the input by start time, which enabled us to make only one comparison as we iterated through at each current item. We just compared this item's start time to the previous end time, and either combined it or started a new interval. We know we only make one comparison because all the start times after the current one must come later. So it's either part of the previous interval or starts its own new interval if it's not overlapping. So that's the foundation of the logic, and now let's finally just walk through some edge cases to fully understand what we're doing. The first edge case says, what if the start time of the current meeting is the exact same as the end time of the previous combined block of meetings that we're comparing it to? In this case, we still merge them. They're still considered overlapping because there's no gap between the meetings. So if the first meeting goes from 0 to 5, and then the next one after it, after we sort the meeting, starts at 5 and ends at 10, then this combined interval of meetings goes from 0 to 10. And then the second edge case says, what if the start time and end time of a meeting come before the end of the current meeting or combined interval? Well, in this case, we still merge them. So we have meeting 1 from 1 to 12, and then meeting 2 from 3 to 9. So the combined interval is still 1 to 12, but we just know meeting 2 is still part of this interval. So now that we have the logic, let's just walk through all the steps of the solution. We first take the input and sort by start time. Then we create the first interval, which starts with the first item since it has the earliest start time. Then we continue to iterate through the items. If the current item's start time comes before the end of the previous meeting or combined meetings, then we combine it with that block. If we do merge, then this means there's additional information available to this previous block. Then we just check if we need to update the end time. If the new item added has an end time later, then this just becomes the new end time of the merge block of overlapping meetings. If it's not merged, meaning its start time comes later than the end time of the previous block, then we just start a new interval, and this is the first item in it. And we just repeat this process until we iterate through the entire sorted input. The big O complexity for this question is O of n log n time and O of n space. The most expensive operation we perform is sorting, which we know takes O of n log n time. And then we create an array to store the merged intervals, which takes O of n space. And now we're ready to write the solution function merge overlapping intervals. First, we check if the input has any items. If it doesn't, we can return immediately with an empty array. The key to the optimal solution is sorting the input by the start time. So we begin by doing that. We're going to track the merged intervals in an array, so now we just initialize the first interval starting with the first item of the sorted array. Then, we begin to iterate through the ordered list of intervals. During each iteration, we grab the last merge interval, or the one with the latest start time, and this corresponds to the last item in the array of merged intervals that we're tracking. So this is the combined interval that we're going to compare to the current meeting time to decide if we should merge this meeting time into the combined block of meetings. We're going to create a Boolean which checks if the current meeting or the current interval, its start time, is within the latest merged interval. So if the start time of the current meeting is less than or equal to the end time of the latest interval. If it is, we know they are overlapping, and we should merge the current item into this block. So to merge an interval that overlaps, all we need to do is check if there's a new end time. Since its start time is after the current start time, we know that won't change. The only thing that can change about the current interval is the end time if we have a new later end time. So we're going to take the max of the current interval's end time, or the most recent merged interval, that entire interval, its end time. Whichever is larger then just becomes the current end time of this interval. If the current interval doesn't overlap the latest interval, then we need to start a new interval. We know the latest merged interval will then have its final start and end time. So we just push the current interval to the merged intervals, which initializes a new one. Then on the next iteration of the loop, this current interval will then become the latest merged interval, which then is the new comparison point. So to recap this loop, if the current meeting is overlapping, all we need to do is possibly update the end time for the current interval to merge them. If they're not overlapping, then we know this must be the first item in the next interval, because no items after this one can belong to the previous or latest merged interval, so this now becomes the most recent one, or the latest one, in the merged intervals array, so now we set it as the latest item. And finally, we return merged intervals, which is the solution. We run the code and the tests pass. So in this question, we improved on an O of n squared brute force solution by sorting the input. And then, by sorting the input, we can go through this ordered data in one pass and make one comparison at each item to determine which interval it should be included in. Thanks everyone, and I'll see you in the next lesson.